So for this problem, we're going to graph g of alpha equals -1 plus 2 sine of 4 alpha plus pi over one period using the transformation method. Now remember, we have another video explaining how the transformation method works, but I would suggest pausing the video now and looking through this one more time just to be sure you're familiar with all the steps. So to apply the transformation method, remember the first step is to solve that inequality. So we're going to take what's inside of sine, which is 4 alpha plus pi, and set it greater than or equal to 0 and less than or equal to 2 pi, and begin solving for alpha. So we can subtract pi from each side of the equations, or inequality I should say, which will give us negative pi is less than or equal to 4 alpha, which is less than or equal to pi. And then if we divide every part of the inequality by 4, we'll get negative pi over 4 is less than or equal to alpha, which is less than or equal to pi over 4. This is the equivalent of 0 to 2 pi that we had before for sine. This is going to represent one period of our graph. It's taken care of all of our horizontal transformations for us. So from here, our next step says find p equals 2 pi over b. So we're going to take p equals 2 pi over b is the value multiplied to alpha, which gives us 4. So we get 2 pi over 4, which leaves us with pi over 2 when we simplify. Just note, you can always take the inequality and take this value and subtract this value to get p as well. I suggest using this one just because it has more usefulness as you go further into trigonometry. From here, we now want to take p and divide it by 4 and then add that value 4 times to the initial value in our inequality. So we find p over 4 is pi over 2 divided by 4. Now this looks messy, but remember we can take any number and put it over 1 and it's still the same number. So if we take this 4 and put it over 1, now we have two fractions that are being divided. We can use the copy dot flip method. You copy the numerator, pi over 2, you change division to a dot, meaning multiplication, and then you flip the denominator, 1 over 4. Copy dot flip, we get pi over 2 times 1/4. You just multiply straight across to get 1 pi, or just pi, over 2 times 4 is 8. This is our p over 4 value that we're going to add 4 times. So we can create a table for alpha, and we start with our inequality value of negative pi over 4, and we add pi over 8 to that 4 times. Now negative pi over 4 with a common denominator of 8 would be negative 2 pi over 8. If you add pi over 8 to that, you'd get negative pi over 8. If you add pi over 8 to that again, you'd get 0. Add pi over 8 to that again, you'd get pi over 8. And add pi over 8 to it again one more time, we get 2 pi over 8, which is pi over 4. And this is a quick check to make sure you're on the right track, that things are going well. If you look at the first and last values of your table, they should match the first and last values of your inequality. So far, so good. Now we are solving for sine. So in this table represents sine of 4 alpha plus pi. And we know the nice thing about this method is these values will always be the same. That's why we're doing it. Sine with the transformation method will always have the values 0, 1, 0, -1, 0. So this table gives us our new period of sine. At this point, we can now list the vertical transformations and then graph. So we'll make a list of our transformations. Nice thing is we don't have to list the horizontal transformations. All of that was done with this inequality. We just start off with our first vertical transformation, which in this case is this positive 2 that's being multiplied to sine. There's no negative being multiplied, so there isn't a vertical reflection. There is just a positive 2, so there is a vertical stretch. From here, there is now a -1 being added to the outside, which means we are subtracting by 1. That represents a vertical shift down 1. These are the only 2 transformations that we need to worry about. Every other transformation was taken care of in this process. So we're going to start by graphing the initial table that we have here. And then that's going to lead to this step where we can then apply the vertical stretch and then the shift down 1. And that's going to give us 1 period of this function g of alpha. So we start off with our table. We have -pi/4 to pi/4. So we'll go ahead and add on some x values. I've already taken the liberty of adding on some y values. So at -pi/4 and +pi/4, and then halfway between each of these we have -pi/8, +pi/8, and then 0 is automatically the origin. So we graph our table, then our transformations. So our table starts at -pi/4, 0, -pi/8, 1, 0, 0, pi/8, -1, and then finally pi/4, 0. Which when we connect these dots gives us something like that. This should look very familiar. That is the graph of sine over 1 period. It's just had some horizontal transformations applied to it. Now we can apply the vertical transformations in order. We have the vertical stretch first. So the vertical stretch is by a factor of 2 here. So I'm going to do this in yellow. So we multiply every y value by 2. We're going to pull away from the x-axis. That's a vertical stretch. So here we have a value of 0 times 2 is still 0. Here we have a value of 1 times 2 is now 2. 0 times 2 is again 0. -1 times 2 is -2. And 0 times 2 is also 0, which when we connect these dots gives us a graph that looks like that. And finally, I'm going to do this last graph, let's say in pink. We're going to shift the entire thing down 1. So this point at 0 is going to go down to -1. This point at 2 will go down to +1. 0 will go down to -1. -2 will go down to -3. And 0 will go down to -1 again. So connecting our dots, remember we were at -1, up to 1, down to -1, down to -3, back up to -1. And then we should label our graph. It's a good way of giving your final answer. So it's good to label it with the function name g of alpha, as circling a graph wouldn't really make sense. It'd look like part of the graph. And that is the graph of one period of g of alpha. If we needed more, we could take this exact shape and transfer it a distance of pi over 2, our period that we found, to the left and right over and over and over again.